Jupiter, the fifth planet from our Sun, reigns as the largest planet in our solar system. A gas giant, Jupiter is composed primarily of hydrogen and helium. These elements swirl in a mesmerizing dance, creating Jupiter's iconic bands and the Great Red Spot, a storm that has raged for centuries. Jupiter's immense size and powerful gravitational pull make it a dominant force in our solar system. Despite its size, Jupiter is not a star. It lacks the necessary mass to ignite the nuclear fusion that powers stars. The core of Jupiter, though incredibly hot and dense, does not reach the temperatures and pressures required for hydrogen atoms to fuse into helium, releasing the energy that makes stars shine. Jupiter's moons, a miniature solar system of their own, add to its allure. From the volcanic moon Io to the icy ocean world of Europa, these celestial bodies hold secrets yet to be fully unveiled. Jupiter, with its swirling storms and enigmatic moons, stands as a testament to the vastness and wonder of our cosmic neighborhood. Stars, the cosmic engines that illuminate the universe, are born from clouds of gas and dust. These clouds, known as nebulae, are the cradles of star formation where the journey of a star begins. These nebulae, vast and cold, hold the raw materials for star formation. They are composed of hydrogen, helium, and trace amounts of heavier elements floating in the cold vacuum of space. Gravity, the architect of the cosmos, draws these particles together. Over time, these particles clump together, forming denser regions within the nebula. This process can take millions of years as gravity slowly but surely pulls the gas and dust into tighter and tighter clusters. As the cloud collapses, it heats up, spinning faster and faster. The conservation of angular momentum causes the cloud to flatten into a spinning disk with the densest part at the center. This process, known as accretion, forms a protostar, a hot, dense ball of gas at the heart of the collapsing cloud. The protostar is not yet a full-fledged star, but it is well on its way. The protostar continues to accrete material, its core temperature and pressure steadily increasing. As more material falls onto the protostar, it grows in mass and its core becomes hotter and denser. Eventually, a critical threshold is reached. The core temperature rises to millions of degrees and the pressure becomes immense. The core becomes hot and dense enough to ignite nuclear fusion. This is the moment when a protostar becomes a true star. Hydrogen atoms, forced together under immense pressure, fuse into helium, releasing a tremendous amount of energy. This energy radiates outward, providing the light and heat that we associate with stars. This energy, in the form of light and heat, prevents further gravitational collapse, creating a stable star. The star enters the main sequence phase of its life, where it will spend the majority of its existence. The mass of a star determines its fate. Stars come in a variety of masses, from small red dwarfs to massive blue giants. Massive stars burn brightly and quickly, exhausting their fuel in a few million years. These stars live fast and die young, often ending their lives in spectacular supernova explosions. Smaller stars, like our Sun, burn more slowly, enjoying lifespans of billions of years. These stars have a more gradual and prolonged life cycle, eventually becoming red giants and then white dwarfs. The process of stellar ignition is a delicate balance between gravity and nuclear fusion, a cosmic dance that gives birth to the stars that light up our night sky. This intricate interplay ensures that stars can shine for millions or even billions of years, providing the energy necessary for life and the beauty that inspires wonder in the night sky. Imagine, if you will, a night sky illuminated not by one sun, but by two. Picture the serene darkness of night, suddenly disrupted by the glow of an additional star. This isn't just a science fiction fantasy, it's a scenario that could unfold if Jupiter, the giant of our solar system, were to ignite into a star. This is the scenario that unfolds if Jupiter, by some cosmic quirk, were to ignite into a star. The transformation would be nothing short of spectacular, a cosmic event that would capture the imagination of astronomers and stargazers alike. The transformation would be nothing short of spectacular. Imagine the colossal energy release, a bright explosion that would light up the cosmos, visible from vast distances across space. Jupiter, no longer a dim point of light reflecting the sun's rays, would erupt in a brilliant burst of energy. This new star would shine with an intensity that would rival some of the brightest stars in our galaxy. The sudden ignition of Jupiter would bathe the solar system in intense light and heat. The familiar darkness of space would be replaced by a new, radiant glow, altering the very fabric of our cosmic neighborhood. The icy surfaces of Jupiter's moons would begin to melt, transforming these frozen worlds into potentially habitable environments. Europa, Ganymede, and Callisto, once cold and desolate, could become warm and inviting, with liquid water flowing on their surfaces. The asteroid belt, a ring of rocky debris between Mars and Jupiter, would be stirred by the newly formed star's gravitational pull. This disturbance could send asteroids hurtling through space, potentially impacting other planets and moons. The night sky, once dominated by the familiar constellations, would be forever altered. The new star would change the patterns we have known for millennia, creating a new celestial map for future generations to explore. Jupiter, now a blazing star, would outshine all other celestial objects except the Sun. Its brilliance would be a constant reminder of the dynamic and ever-changing nature of our universe. The familiar patterns of the zodiac would be rearranged as the new star's light drowned out the fainter stars. Astrologers would have to rewrite their charts, and the zodiac signs would take on new meanings in this transformed sky. The transformation of Jupiter into a star would be a cosmic event of unprecedented scale, forever changing the face of our solar system. It would be a testament to the incredible forces at play in the universe, reminding us of the delicate balance that sustains our cosmic home. This new dawn in our solar system would mark the beginning of a new chapter in the story of our universe, one filled with wonder, discovery, and endless possibilities. Section 4: Cosmic Ballet: Gravitational Impacts on the Solar System. The solar system, a vast and intricate dance of celestial bodies, has maintained a delicate balance for billions of years. Each planet, asteroid, and comet follows a path dictated by the gravitational forces exerted by the Sun and other massive objects. The ignition of Jupiter would not be a mere light show. It would signify a profound transformation, turning the gas giant into a second sun. This change would have far-reaching consequences for the entire solar system. The gravitational balance of our solar system, carefully orchestrated over billions of years, would be thrown into disarray. The Sun, which has been the primary source of gravitational pull, would now share this role with a newly ignited Jupiter. Jupiter, now a star with significantly more mass, would exert a far stronger gravitational pull on its surroundings. This increased mass would not only affect the orbits of nearby objects, but also have a ripple effect throughout the entire solar system. Planets, once following their predictable orbits around the Sun, would experience perturbations, their paths subtly altered by Jupiter's newfound gravity. The inner planets, including Earth, could face significant changes in their orbits, leading to potential shifts in climate and environmental conditions. The asteroid belt, caught between the gravitational tug-of-war of the Sun and the newly formed star, would become unstable. The delicate balance that kept these rocky bodies in place would be disrupted, causing chaos within the belt. Asteroids, once confined to their orbital path, would be flung inwards towards the inner planets, increasing the risk of catastrophic collisions. These collisions could have devastating effects on any planet they strike, potentially altering the course of life on Earth and other planets. The outer solar system, home to the gas giants Uranus and Neptune, would also feel the effects of Jupiter's transformation. These distant planets, which have long been influenced by Jupiter's gravity, would now face even greater disruptions. Their orbits, already influenced by Jupiter's gravity, would be further disrupted, potentially sending these giant planets on new trajectories through the solar system. The gravitational interactions between these massive bodies could lead to unpredictable and chaotic movements. The once stable and predictable dance of the planets would become a chaotic ballet, with Jupiter's newfound stellar status leading the cosmic choreography. The solar system, once a harmonious and orderly system, would be transformed into a dynamic and unpredictable environment, forever changed by the ignition of Jupiter. Section 5: Earth's Fate, a World Transformed. The fate of Earth in this scenario is uncertain. The increased radiation from a stellar Jupiter would undoubtedly have a profound impact on our planet. The delicate balance of Earth's atmosphere could be disrupted, leading to unpredictable and potentially catastrophic climate change. The increased heat from Jupiter could potentially boil away our oceans, rendering Earth uninhabitable. On the other hand, the added light and warmth from a second sun could create conditions favorable for life in previously inhospitable regions. The polar ice caps could melt, opening up new shipping routes and potentially revealing hidden resources. The night sky, once a familiar tapestry of stars, would be dominated by the brilliant light of Jupiter. The constellations, those celestial signposts that have guided humanity for millennia, would be lost in the glare. The moon, once a beacon in the night sky, would be outshone by Jupiter's brilliance, its phases barely perceptible. The transformation of Jupiter into a star would have profound and far-reaching consequences for Earth, reshaping our planet and our place in the cosmos.